Welcome to Math 25 in week 6. A couple of announcements and then we'll start doing new math. No one had questions to start with, and normally I would make up something to help us review a little, but that's built into what we're doing today, so I don't have to do that extra. The first announcement is there's a new achievement. If you go down and look at the achievements links, then there is Math Flicks. Watch a math video with a classmate and talk about it together afterward. So I know that people are wanting more ways to sort of connect with each other despite social distancing. And we had some things about let's actually do something, produce something together. But it can be nice just to absorb something and not have to produce. So if you pick a video, whether it's one of the videos from the example problems of our online textbook or a video from a different website, then let me know. Tell me what you and the other classmate talked about afterwards, and then I'll check off that achievement for you. The other announcement is up at the top of our links with the things going to other websites. We have the Math 25 Moodle tutor forum. No one has asked any questions for Greg yet. So if you have homework questions, feel free to ask me as always. And if I don't explain it in a way that makes sense to you, ask Greg also, or if you just want two versions. Okay, today we're doing personal finance. We've done lots of this stuff to build up to it, talking about typicality, what's most common or representative, talking about bell curves. We did mortgages, which isn't really about saving for retirement. It's a different section, but it's part of personal finance. And then we've done a bunch of stuff about saving for retirement, talking about what interest is and how percentages work. Simple interest, compound interest, sum of annuity due were 3 different formulas. And now we're going to start putting them all together. So that's the warm up for today, or announcements for today. So our first thing is how much to save for retirement. And we're going to use the word typical American expenses, but we know about this word. So think about if it is something that is actually frequently occurring around where we live, or representative of a group of people and what that means. But typical American retirement expenses are greater than the retirement income by about $20,000 a year. So if this box represents all of your retirement expenses, then some of these expenses are covered by your income. Whether you have pensions or Social Security or whatever it is that's giving you your retirement income, then that's okay. Then the other part is why you are saving. So these are the expenses you'll have that need savings. So if this is a box of each year, how much do you need savings for? For the typical American, it's $20,000. Now the rule of thumb, and again, don't trust your math teacher. This is just a very common rule of thumb that you'd find in most investing books or websites. But if you are, or your parents or family members are thinking about investing seriously and retiring seriously, then get some more authentic professional help than just this rule of thumb. But the general rule of thumb is to save $20 for each dollar you would need to spend each year. So during your year you're 65, you need 20,000. During the year you're 66, you need 20,000, and so on. So we'll take these and times $20 as our scale factor. Actually, I'm going to be nitpicky and say it's times 20, not $20. And you need 400 overall. If you have that much saved by age 65 and you are a typical American, remember we've talked about what that means, then you're good. And we'll leave it at that. This is just our goal when we're looking at some situations in the next hour. Did this person save 400,000 or not? We'll give them a thumbs up if they do, and we'll be worried about them in a hypothetical way if they didn't. The reason that number is 20 is because then you would have $1 for each year for 20 years. That would get you from age 65 to age 84. Hopefully you want to live more than 84 years, but for the years 85 and beyond, the interest from your savings will cover it. Okay, so that's our sort of setup for the day. Do different people save 400,000? And that's why we want that question. Everyone okay so far?
Yeah.
So we're looking at three sisters, Cindy, Clara, and Chloe, and they, because it's a math problem, have similar numbers happening in different ways. This isn't the most realistic family, but that's okay. We're in a math class. So Cindy is going to save $3,000 into savings every year for 10 years when she's young. We're not sure exactly why. It says here, I'll wait till my kids are older, then I'll enjoy the vacations more. Once she turns 35, for the other 30 years before she retires, she will not save anything, and she'll put all her money into vacations. So how much will Cindy have saved when she retires at age 65? Let's do that one. Okay, so we had three different formulas. Simple interest, compound interest, and sum of annuity due. So does someone want to remind us what's the difference between them before I give my words to it? You've heard my words, so I want to let your classmates hear your words too.
Is it simple interest like the added 2% or whatever on to each month or something? Or is that compound?
Compound interest is the one that's most often monthly, and that's
Okay.
where whatever the interest from 1 month earns keeps earning the next month too. The interest earns more interest. The payments get bigger and bigger.
So compound means payments get bigger and bigger.
Yeah, compound means the payments get bigger and bigger. What was sum of annuity due, the new one from last Thursday?
Yeah, that's the has to be done in
It sounds like your mic is having problems, Donna. Do you want me to talk or are you answering?
Oh, sorry. Is some of, I can't talk this morning. Is that the one where it has to be done in years?
Yes, this one is always years. What made Sum of Annuity Due special compared to the others?
I can't remember.
Okay, then I will remind you. So simple interest, you have just one deposit. The principal you just loan out once or borrow a loan once, and then you do the same payments each time. Compound interest also has just one loan. You're borrowing money once, you're lending money once, and you're watching what happens, usually month by month, and the payments grow. Sum of Annuity Due, that's the one where you're depositing again and again and again, always the same amount. Every January you're putting money in. So that's the only of the three with repeated principals, repeated deposits. Okay, with that out of the way, which one do we want to start this problem?
I'm thinking, I'm not sure, that the sum of the
Yes, the Sum of Annuity Due is how we start. For 10 years, she keeps putting money in. So that's the Sum of Annuity Due. So that's part A of this problem. Then in part B, she stops saving, and for the final 30 years, she spends it. So for 30 years, she's just watching an initial amount change. Which formula will that be? Compound, good job. Simple interest never really applies except for things like payday loans and government bonds. Anytime in real life we're talking about loans with people, we almost always, except for payday loans, have compound interest. Okay, everyone okay with my highlighting so far? We have one formula with repeated deposits, and then we're just watching something change, but not fiddling with it. Okay, so let's get that formula. We had talked a lot last class that for a complicated formula, which compound interest often is, then I want to organize myself before I dive in and make sure that the rates and the time frame and everything matches the compounding, if it's months or weeks or years. But in this case, everything is years. There's really not much to get organized. I'm just going to dive right in. So Sum of Annuity Due formula, we start with the principal. And remember that only in this formula, this is a repeated thing. Every year she puts in 3,000 more. The 1 plus rate, I'll have to go back and read my problem to see what the rate was. Here we go. All three retirement accounts earn 8%. So for my rate, I'm going to start with a 1 plus rate, 1.08. Now remember we talked about these square brackets. That's just big brackets, but I'm writing them with typewriter conventions. And those I have to keep around. So I'm going to actually make them kind of big. Here too. See if I've spaced that right. The middle brackets, or the mini brackets from the 1 plus rate, I'm just changing that into 1.08. I don't need those parentheses. Okay, 1.08 again. The number of years was 10. And then there's no 1 plus here. Somebody is going to put a 1 there on the test because you're so used to it after putting a 1 in front twice, but there's no 1 there. Okay, we've plugged everything in. We've kept the parentheses we need, the bigger set. Now it's the calculator's turn. So call out the answer if you get it faster than me.
$10.8.
I'm getting $46,936.46.
Oops.
Oops. Try again and see. Remember to use the right key for your exponent, not the one that says EXP, but the one that has y to the x or the caret symbol like a mountain. Remember to use your parentheses.
I just totally skipped the exponent part.
Ah. Yep, if you totally skip the exponent, that will not work. Make sure everyone gets this before I move on.
I got 39,6,900 or yeah 00.
3,000 times 1.08 times parentheses 8 exponent 10 minus 1.
Oh, exponent 10. That's what you did. Okay. Sorry.
I think it's mine. I've done it twice now. Get your calculator working, because if it doesn't work now, it won't work on the homework. So get it working now.
Okay.
Oops, not a triangle, just a... Everyone get it?
Bluetooth mode.
Yeah.
Connecting. Please wait. AUX mode.
Did it work for you yet, Donna?
Almost. I'm almost.
Okay.
I got 6,9 something. I'm doing something wrong.
So what I am writing out for my calculator is the 3,000 times the 1.08 times parentheses 1.08, then my y to the x key, then 10, then minus, then 1 close parentheses divided by 0.08 and then equals. Does that help?
Yeah. David, the YX is what's getting me.
Okay, tell me more. Is it that you can't find it, or you have the mountain bracket thing called a caret instead, or?
Yeah, I have the little mount kind of look and try.
Okay, so you're going to use that one instead.
Yeah, I got it.
There are a few calculators, not many, that after you do the exponent, you have to hit some sort of arrow key to say come down from exponent area. But most calculators don't need that.
AUX mode.
Got it, David. Yay. Thanks for patience.
Okay, no problem. Now we need to do part B. I'm out of room, so I'll move to a new slide. Let me capture a lot of this. So now we're on part B. Instead of the sum of annuity due formula, we decided we wanted the compound interest formula.
Note.
So how much is she starting with?
$3,000.
Oh,
Before.
it's this amount, right?
Sorry, that
Whatever she had before, she still has that. She's just watching it grow. So that's the principal. It's kind of big. So that amount is what's in her savings account at the moment she stops saving, and for 30 years just watches what happens. So that's the tricky part here. When you have these two-part problems, then when you switch to part B, pay attention to how much your answer to part A was. Okay, 1 plus the interest rate is again a 1.08. You're good at that. And how many payouts? There's 30 more years. Sometimes the problem itself will say compounding monthly or compounded annually or so on. This time it didn't, so we just assume it's annually. That's our default choice. Okay, so now the calculator again does its work.
472305.
Yeah. And I'm just going to round to dollars because why not? Okay, so our goal, remember, was $400,000 to save for retirement. And she made it. She had actually quite a bit more. Everyone's calculator did this part also?
So is this 400,000 per person?
This is kind of vague. We don't know, in this, the story wasn't very explicit. It is Cindy living by herself. She has kids, right? Is this the only person in her family saving for retirement or not? The recommended thing when you're asking about that is usually by household. So I think this one is per person, but you'd actually want to think about it with a household. Simon, when you go, close the door all the way.
Okay, do you know where Mastermind is?
Yes, on the sitting room. Close the door, Simon. Oh, sorry about that. So I think this is per person, the 20,000, but when you actually do the planning, do it for your whole household. Okay, but Cindy's okay, whether she's carrying her husband or whether they're doing this together. Okay, ready for the next person? So her sister Clara is doing the opposite. For 10 years, she is going on vacations and not saving anything. And then for 30 years, she's putting all the money in. So she's spending her own money a lot more often, right? 30 times instead of just 10. I realized I'm answering Timothy's question badly. Okay, so I get, that looks funny. Grab it without. So we again have 3 kinds of formulas. before I write on them, I'm going to be smart this time and copy that for the next slide. Okay, which formula do we want for this situation?
Compound.
Compound interest is when you have one amount to start with, and then you just watch it for a lot of years.
Sum of annuity due.
Sum of annuity due. So because she's putting her $3,000 in this savings every January for 30 years. For the first part, we don't have to worry about that. Oops, let me draw. We don't have to worry about that at all. She's not saving anything. So there actually isn't a part A and a part B. It looks like there is because she changes her plan halfway through. But since part A was just 0, then we can jump all the way to part B. I will write that out though. Part A, no savings. Okay, so let's go to sum of annuity due. As before, these parentheses are important. The other ones we're just going to turn into a number a little bit bigger than 1. We still need to know that the rate is 8%. So her principal is 3,000. Since it's sum of annuity due, that's a repeated thing. The rate is 0.08, so we get a 1.08. Here I have my parentheses. She's doing this for 30 years. And we're dividing by 0.08 without the 1. And again, for the people arriving a little late, these inside parentheses you don't need because 1.08 is so easy to write. The outside parentheses you do need. You will get the problem wrong if you neglect them. So the calculator does this work for us, 3,000 times 1.08.
367,037 and 60.
Okay. I'll just round it to the nearest dollar.
Yeah.
So did she get to her $400,000 goal?
No.
The more I think about it, the more I like Timothy's point that this is sort of her responsibility as a grown-up for herself. We're not sure if she's married, what's happening with her spouse or partner or whatever. So she's close. She's not there. Okay, Is anyone surprised by the difference?
Hmm.
20 years made it.
What happened?
So the first sister only saved 30,000 total, right? 3,000 10 times. But because she started so soon, it turned into a lot more than she needed. The second sister saved 90,000 total. For 30 years, she put in her 3,000. But she didn't get quite as much because she started 10 years later. So one thing we're learning today is start early. Even if you're a teenager who can only save 40 or 50 bucks a month for retirement, it will matter a lot by the time you get to be 65. Okay, the last sister said, both of you are kind of a little bit fanatics. I want to do things in moderation. I'm going to save 1,500 every year for all of the years. So she has 10 years and 30 years. So for 40 years, she's doing her plan. I'm going to make a note up here, 40 years. Okay, which formula are we using?
Compound interest?
That would be if there's one deposit that we just watch it happen, like the second half of Cindy.
Oh, that's
That compound.
This is sum of annuity due again, because she is repeating 1,500 again and again and again.
right.
So her repeated amount is 1,500. Her rate is still 1.08. Keep those bigger parentheses. Her years are 40.
Wow.
What did she get?
419,672.
419,672. That what everyone got?
Yeah.
Okay. So she is, she didn't start early enough to benefit from being really early, or she did, but not quite as much. She did start early enough to benefit from being early, and she didn't have to deposit the whole 3,000 each time. So in real life, most households are a mix, right? They don't save enough in the early years, and then they start saving when they get older, but they don't usually save enough. We did 62 last time. So let's do something similar to 62, but with, how about like Dutch Brothers?
Oh dear.
So imagine somebody, certainly not anyone we know,
Oh
that
no.
buys a Dutch Brothers coffee every morning, or maybe even just every weekday morning on the way to work. How much are they spending?
$30 a week.
$30 a week. So 6 times 5, you're thinking it's a $6 thing they're buying?
Well, no, they're usually about $5 actually. Sorry, so like $25.
Okay, so every weekday $5. So weekly 25. So annually 25 times 52,
1,300.
1,300. So we're going to go back and use the sum of annuity due formula. How many years and what rate should we use?
1 year.
How many years?
1.
One. No, we're not going to start this when we're 64. So how many years until they retire?
Oh. 45?
45. So
We know how
this person
old
we're
it-
looking at now is about 20 years old.
Sounds
Okay.
about
And what rate are they getting? The 8% we were doing is average for the stock market, but that is a little ambitious. Maybe we should go with 5 or 6%. They have
Yeah.
some bonds also.
5% sounds good.
Oh, okay. So this becomes a 1.05. 1.05. Make that look like a parentheses and not a C. Exponent 45 minus 1.
I must have done something wrong somewhere.
I'm getting about 217,000.
Wow. Yep, I definitely did something wrong somewhere.
Make sure you have the parentheses. Make sure you didn't make a 1 here.
Oh, I forgot the. No, I didn't. Oh, my. No, I did it all right. That's weird.
Let me double check then. 1,300.
Yeah.
0.05 times parentheses.
Times point. Times 1.
I'm getting the same thing again.
I got what you got, David.
Oh, okay. Everyone get their calculators working because you won't do the homework without a working calculator.
I got it.
I know sometimes I forget those parentheses. I forget to close it. I remember to put it in the beginning and then
That's
I
what
forget to close it. It gets
I accidentally put times 0.05 at the end instead of divided by.
That's
So-
fine.
Number was quite a bit smaller than what you guys had.
Yes. Well, good job. Make all the mistakes now when it doesn't matter, and then you'll get the homework right.
Right.
Yeah. It's a fairly physical skill doing all of this with a calculator, right? You know how in your brain. It's just hitting all the buttons right.
Exactly. Your fingers like to get tongue-tied sometimes.
Right. or you start thinking about something more interesting than calculator buttons and get distracted or whatever. Anyway, so here we go. Moral of the story: you're not going to make all of your retirement savings, but you can get about half of them if you kick the Dutch Brothers habit. Right?
Man, I'd be happy with $217,000.
Depending on where you live, remember all
Me
this
too.
thing about typical and so on. Does the average person living in Cottage Grove need as much as the average American? No, right? Standard of living costs for things are lower
Mm-hmm.
in certain parts of Oregon. You can certainly retire comfortably in Oregon with a less than American average amount of money.
Especially if you live in Tennessee.
That's true too. Okay, let's do one other one. I'll give away a homework problem for you.
Yay.
So, okay, so on the actual homework page, you can follow these links and see that yes, Oregon is unusually expensive for childcare. Whether you go to Vivian Olem or the LCC one or the eWeb one, then sort of the big three in town cost $13,000 a year roughly. So we're going to have a part A and a part B. Part A, we're going to have save 13,000 for 2 years. Somebody said I could pay for childcare, but instead I'm going to put that money in savings. And then part B, we're going to just watch it. For 16 years. So part A is obviously sum of annuity due. We're putting money in year after year, even if only twice. It's a 5% rate. And it's not going to be much more than 26,000 because it's only 2 years of stuff happening.
$27,982.50.
$27.09, what, 982?
Yes.
50 something?
50.
50, okay. Then we're going to just watch it grow. Which formula is the watch it grow formula?
Simple interest.
That would be if it always grows at the same rate. But
Oh my god. I'll get these doggone things eventually.
yes. Yeah, so this
Yeah,
is
me too.
because the interest will earn
Greater and greater for compound.
and it is normal that it is confusing about which to use when. That's why we're doing this and why I'm giving away a homework problem.
Okay, so what if you did use the wrong formula?
Then you get a terribly different answer, because if you don't have the compounding happening, then you're missing out on a lot of interest.
Oh, that sounds fun.
You can always do the wrong formula on purpose and see just how what compound interest is.
$61,082.28. Oh yes, leave the 28 out.
So why is this important? Well, one reason that middle class Eugene Springfield families struggle is they're trying to have both parents work and they're doing childcare. And many families have less expensive options than these big three, but lots of people do the big three. And then in addition to that, when the kid turns 18, they're paying for college. And you can see that if you somehow had the cash available when your kid was born, as unrealistic as that is,
Yeah,
you just set aside that money, the 2 years of 13,000, you could pretty much pay for college, right? You could go to LCC for 61,000. That's not going to get you through Harvard, but you could get a good amount of community college for that amount. So people are basically paying for college twice for their kids, once when they're infants, and then once again when they're 18. Because if you didn't spend the money for childcare, then it would have turned into this much later on.
right.
Okay, so David, can we talk some of the key words that help us know which formula to pick? Like you keep
Sure.
saying for compound, greater and greater, and sum of annuity is year after
The basic
adding and
situation
adding.
is for simple interest, we're just not using that with these types of stories.
So we're not using that at all.
For payday loans and government bonds, and that's about it. So it is the repeatedness, which could be the word each. Each year, Cindy puts 3,000 into savings. Or you could just tell that it's repeated. There's no word each in this one, but you can tell she is repeating the 3,000 every year for 10 years. Then the compound interest is for when there's no more deposits happening. Whatever you have in your savings is just growing. Whatever your credit card debt is just growing. You're not changing the story any. You're just watching what happens.
Okay.
So for Cindy, first we had to do sum of annuity due because she was putting in that 3,000 each year. And then for 30 years, she wasn't putting in more money. We were just watching what happened to the 46,936 she had before. Does that make sense as a contrast?
Mm-hmm.
Yes, thank you.
And her other sister, Clara, every year she put in 3,000. So it's repeated. So it's the sum of annuity due. And for the third sister, Chloe, every year she put in 1,500. So it's repeated. So it's the sum of annuity due. And then for the Dutch brothers, every year we were putting in that. So it's repeated. So it's sum of annuity due. And for this one, the two-parter, there were 2 years we repeated. And then after that, we were just watching what happened for 16 years. There was no more money we were depositing to save with. So that makes it compound interest. Does that answer your question well enough?
Mm-hmm.
Yeah.
Yes, a lot.
Oh, okay. Let's go back to our lecture. We've done all that. We've done all that. We've done all that. Okay, to recap again, when you do the math for Clara at the beginning, you think, oh, of course she made it. Who has $3,000 a year to put into savings when you're at age 25? That's unrealistic, which is sensible. But the Dutch brothers example, the smoking example from last time, said, well, you can often get a lot of the way there just by adjusting your spending. If we had factfulness in our laps, we could do this, but we don't. So there we go. Okay, so we are done with the personal finance decisions. We still don't have a single formula that does everything we want, right? In real life, none of us are going to save the same amount repeated again and again and again. But this gives us the tools to think about it and say, whoa, starting early really helps. Starting early with half as much still really helps. Doing a small amount a day really adds up. So the tools can give us the right lessons to learn, even if they are still just formulas and doesn't predict how much you or I will have at age 65, because we are not this methodical and repetitive. Let's look at the turn-in problems again. So problem 1, 2 different paintings, $100 or $200. They both increase by the same dollar amount of 30. Find the percent increase for each. And why do they have different percent increases if it's 30 for both of them? Does that make sense to everybody?
Yeah.
Yes.
Okay, then we have simple interest problems. Number 2 is a very standard one. Number 3 we did in class. That simple interest still happens sometimes. You should know what it is. If you haven't read the article about check cashing in real life, that's a good one to read. Number 4, we've done 2/3 of this. There was a weekly example, there was a monthly example, and there was an annually example. And I think we did the weekly and the annually. So you can steal those from the lecture notes and do the monthly yourself or something like that. Then we start getting a little trickier. Number 5 has more than one part. There's a $100 deposit and it increases for 30 years. Which formula is that when you're watching one thing change?
I want to say
Yeah, compound interest. It's not $100 per year. It's just a single thing that you're watching change. So that's compound interest. And it's annual, so the formula is nice. Then part B, let's put in more money, but just once. So this is still compound interest. It's just that whatever the answer you got for part A, you have to make it 10,000 bigger. But after that one adjustment, now it's another compound interest, a certain percentage, a certain number of years. What's the overall amount? So 2 parts, both compound interest. We talked about annual effective interest rate. That was where you assume it's a $1 deposit, and at the end of the problem, subtract away that single dollar. So everything else is interest. Number 7 and 8 are a little confusing to read, so let's talk about them. The average American, according to research by this company Vanguard, who's under age 25, has saved $3,865. So let's imagine that, Mark has done that. And that's all he does. He's just going to take that amount because somehow he has that much saved for retirement at age 25. And he's going to invest it with 9% for 40 years until he's 65. So how much will that grow to be? It's going to be less than this number. This is how much the average 65 or older has saved, the 176,696, which, by the way, is a lot less than 400,000. Americans are not good at saving what they should. But the answer to this imaginary person is not going to be a lot less than this. It's going to be surprising that people on average start with a little nest egg, and most of what they end up with is just that nest egg enjoying compound interest. So you're going to take the 3,000 at 9% for 40 years and say, oh, it's almost all of this bottom bar, but not quite. And that's kind of depressing that people aren't saving more as they go, because it's not that hard. Number 8 is very different. You're going to try working in another direction. You're used to taking compound interest and plugging in the principal and everything else and getting out the final amount. But what if we work backwards? We're saying what annual deposit would become this average American savings if it was 40 years and 9%. So to do this, because of the exponent in the middle, then you can kind of do it the math way with the equation, or you could just guess and check and put in some numbers here and see what you get. And if you're too little, make it bigger. If you're too big, make it smaller. And you will find out that the principal that works is more than 400, but less than 550. So people on average in America should be saving 400,000 according to the recommendations, but on average they're saving 176,000, and that's only equivalent to $400 or $500 a year. So you might not be able to save 400,000 by the time you're 65, but can you be an average American and set aside about 500 a year? Sure, most people can do that. This one we just did. And number 10, oops, there shouldn't be an S there, talks about how we don't need to know what the principal is. This is from the Rule of 72. Let's go back and look at that. The Rule of 72 said that the percent increase and the number of times before it doubles, those two will multiply to 72. If you're at 3%, it will take 24 doubling, or 24 interests, because 3 times 24 is about 72. So if we have something that gets 10% stronger each time, how many times do we need to double? 10 times what is about 72? 7. If it gets 10% bigger 7 times, it has doubled. So in a computer game, somebody is at 20, somebody else is at 27. It's gotten 10% bigger 7 times. So ta-da, it's twice as big. And that's kind of amazing. We can say it's twice as big when we don't know how big it is for either of them. That's just how the rule of doubling works. For the turn-in homework, or the random homework, the ones you'll get tested on, then we have simple interest. It says simple interest. There's the simple interest one with the post-dated check. It again says simple interest. Here's the one that goes up 18% and then down 18%. I'm sorry, up 18% and then down a certain amount to get back to where you started. But the second year's percentage is going to be smaller than 18 because it's a bigger amount, so you need a smaller percentage to have the same change. Then we have a 2-part problem, and then we have another 2-part problem. This one has compounded this and compounded that, so it's going to be compound interest for both parts. This one has each year. So what formula is that one?
Sum of annuity.
Yeah, sum of annuity due. Part A, sum of annuity due. Part B, she stops making deposits. She just watches it grow. So that part B is going to be compound interest. So 5 things to practice for the test, and the homework to turn in. We've gone over more than usual because it's unusually complicated.
Yeah, I'm done.
Okay, questions on anything? Congratulations on finishing personal finance.
No questions.
So there's a study session today at 2. If anyone wants to show up and do homework together, you can. And otherwise, I will see you Thursday. Bring lots of questions. So I don't want saving for retirement to be due very soon. You should have questions for it, and we'll keep doing lots of questions on Thursday. Since we have a few minutes, let me just do a quick overview of the next thing. Don't bother to take notes or remember this well. For business decisions, we're going to talk about margin and markup and profit. Almost everyone uses the word profit in an inaccurate, sloppy way. But since part of math is using words precisely when talking about numbers, we're going to learn the right vocabulary. We're going to talk about different kinds of how to price things. And there's entree pricing because culinary students are required to take Math 25. We're going to talk about charge options. Have you ever been to like furniture stores as the classic example, and they have 0 down plans and all sorts of things like that? So this is categorized in business decisions as if you are running the business. Why would you offer the different options? But it's sort of personal finance because you might have to decide which option you want. So understanding them helps the consumer also. And then we're going to end with a little bit of probability. So probability and odds and what's the differences between them, and this thing called a weighted average. We've talked about mean and median already, and weighted average will finish up our different kinds of averages discussion. And this is a much shorter overall section than the personal finance decision is. So remember, health went by faster than personal finance. This is more the size of health. So we are in week 6, but we're still probably going to finish business decisions early enough to have at least 2, if not more, review days before we take our end of term exams. I will go ahead and make a personal finance decision midterm. So am I allowed to compliment the person who did a nice midterm in public?
Sure.
Okay, so that's okay. I want to have her know. Not have someone else give her permission to be outed. She's smiling. Okay, so Donna did a great health decisions midterm, got the check mark for that. You don't get 2 check marks for doing 2 midterms with 70% or more. But if you want to try it just to know how you're doing, you can do more than 1. Or if you didn't want to try this one and are waiting, then I'll have down at the bottom a personal finance decision midterm to try. You can always try the random ones as many times as you want. And I would before trying the specific one I give you. But I'm just going to print out one so I have the answers and you don't. And then I can grade it when you send it in. That's the only reason it's special. And these, once again, are only the random homework problems. There's nothing here you haven't seen if you've been doing homework properly by first looking at the lecture notes and then trying some random problems and then turning in the turn-in problems.
I haven't done any of the random problems. Oops.
Yeah, if you've been skipping them, then you have more test studying to do than other people.
Right.
So,
Okay.
you can either, because they're the same problems, just say, I'm going to ignore the random problems and look in the playgrounds for the practice tests and start doing those. Or you could go back and do the random problems as homework.
Oh, I did have a question. That speed quiz there on the top,
Mhm.
isn't it supposed to pop up with some sort of timed quiz?
It's not timed, just time yourself. So what this is in the achievements, and one of many ways to get stars, because again, I don't care which stars you get, you just need so many stars with the green background, how real math works, right? So this 3-minute multiplication quiz, if you try this and it works, then tell me you've done that. You can multiply 2 5-digit numbers in 3 minutes or less and you get a star. The representational fluency.
Oh, I see now. Okay. I was completely lost on that little grid that was there. I was like, what in the, why is this? What is this?
That's just to write things down neatly, because a lot of people, if you give them a time limit, their handwriting goes kaput and it wanders all over the page. So having it organized for you helps you be fast.
Right.
This one, I need your help. I just made this up last week. I have no idea how long this takes on average, if it's like 5 minutes or 2 minutes or what. But the idea is that you know 10 different ways to say 47 hundredths, which you probably haven't realized yet, but congratulations, you are that smart. So let's do the matching. Let's take these 10 different ways to write 47 hundredths and match them up. So if you do that, then we'll check off the representational fluency thing. So you don't have to do these, but they're pretty quick and easy ways to get check marks to get a better.
And so you just want us to write those out on our own sheet of paper or whatever, and take a snapshot and send it into you through email?
The snapshot's nice, not necessary. If you print them, you can just print them on a paper. If you want to just copy things on scratch paper while staring at a screen.
Oh, and then make lines to each one.
Yeah, it's just to draw lines. I can't draw
Gotcha.
lines. And then the answer is at the bottom. You can see which ones are officially the right ones.
Right.
So this one's mostly just so you realize how smart you are, because most people don't realize when they know 10 different ways to think about 47 hundredths. Everyone know why 47 is the number I'm using?
No clue.
Yeah.
No.
So the college in California named Pomona in the Claremont group has 47 as its theme number. And there's a remarkable number of coincidences about 47 if you study the lore of this college. And one of the writers for Star Trek was a graduate of that college. And so he loves the number 47. So if you are a Trekkie, you are aware of this 47 thing, that every episode there's some just arbitrary number where Picard says, our shields are down to 47% or something. There's always a 47 as like an Easter egg in Star Trek episodes. So if you are nerdy, 47 is the stereotypical number if you just have to pick a number.
Interesting.
Okay, well, have a good either a couple hours if I see you at 2, or a couple days if I see you Thursday.
All righty. Have a good one.
Thank you, everybody.